Okay, good day, everyone. We're gonna get started on a new chapter, and I'll finish grading all your exam number one, and most of you guys did pretty well. And I will post the solution, right? Probably next week sometime. I'll post the solution to the exam number one. And still, a couple of your classmates have a medical emergency, so they have to make up the exam number one this Friday, and next week I'll be able to provide you with all the solution menus, so you can check the solution menu and get the feedbacks from there. All right. Do you have any question? Okay. All right, so we're gonna look at chapter 3 today. We start talking about simple and compound interest today, right? Okay. All right, can you see the screen?
Yes.
Okay, thanks for your answer. Okay, so today we're gonna start on a simple interest and compound interest. Okay, so this is a very important financial instrument, right, in the corporate America. And also in the banking system, they usually use the compound interest, right? That's popular means of calculating the interest. Okay, and let's take a look at difference between a simple interest, compound interest. So nowadays, very few banks, pay interest based on the simple interest formula. They usually pay the interest based on the compound interest, right? Compounding. Okay, and the difference between simple and compound interest is a simple interest grows very slow. Compound interest actually grows slightly faster compared to the simple interest. So compounding speed up the process, meaning the money is working harder under the compound interest. And the reason why the money is working harder, because for the simple interest, you only earn interest based on the principal amount, right? Principal amount generate interest. But for compound interest, both the principal and also the earned interest, meaning interest earned from the previous periods, also they both generate interest. So that's why the money is working harder, right? Money is working harder under the compound interest. That's why the compound interest is always better, right? This is a better option. Any questions so far about this comparison between these two financial instruments? Okay. All right, so now let's look at the simple interest formula. All right, so the total amount of interest, we're using I to represent total amount of interest. It's calculated using P times R times T. Here, P represents the principal amount, and then R represents annual interest rate, and then T represents the time in years. So for example, let's say if you want to calculate interest with the principal $1,000, with the annual interest rate, which is 5%, T equal 5 years. And then what you have to do is just multiply across. So interest equal to principal 1,000 times interest rate 5% times 5 years. And here the 5% becomes 0.05 times 5. And this turned out to be 0.25 times 1,000, which is $250. Right? So the interest earned over 5-year period of time will be $250. And each year, on average, you are earning $50 interest because interest rate is 5%. Okay. And this is the simple interest. Okay. And then so the total amount of money obtained, right? Ending balance. You can call this A as ending balance. It's equal to principal plus interest, right? So ending balance is equal to principal plus interest, and interest is basically using P times R times T, principal times annual interest rate times time T in years. And then principal adding interest earned becomes the total ending balance. Okay, that's what we mean by this. So now let's take a look at the example. Let's say, consider this example. You begin with $100, invest at 10% annual interest. So you want to find out what is simple interest. Under simple interest will be the balance, right, after the first year. So the ending balance equal to principal plus principal times interest rate times time t. So since here 1 year meaning t equal to 1, we know P is $100. Interest rate R, that's 10%, which is 0.10 or 0.1 if you want to simplify that. All right, so now next step, you just throw in the numbers into the formula. So we get $100 principal plus $100 times interest rate, which is 0.1, times time t, which is 1 year. Okay, so it becomes 100 plus 10, right? Meaning at the end of year 1, you get $110. Okay. And then if you look at time t, which is equal to 2. So here, the second one, 2 years, time t equal to 2. Principal is the same. Rate is 0.1. Now again, you just follow the formula. Okay, so the A equal to P, which is $100 plus 100 times rate, which is 0.1 times T, 2 years. So it becomes 100 plus 100 times 0.2, which is $20. So it becomes 220. Okay. Now I want you to complete the rest of the table, right? For T equal 3 years, 4 years, 5 years, 10 years, 20 years, and 50 years. I give you 5 minutes to finish this really quickly using the simple interest formula. Okay, let's go over the solution. Anybody want to share your answer? Okay, for the third case, t equal 3, and then principal is $100. Rate is still 0.1. If you follow the formula, A equal to P principal plus principal times rate times time t. You're going to see something very interesting. 100 plus 100 times 0.1 by 3. And this turned out to be 100 plus 30. And this is $130. As you can see, as the year go by 1 year, right, increase by 1 year, then the interest collected is increased by $10. Okay, look like there's a straight line pattern here, right? Like constant increase. So when t equal to 4, very similar, you're gonna get interest earned will be $40, and the total is $140. So A equals 100 plus 100 times rate is 0.1 times time t equal to 4. So it's 100 plus 40, which is 140. Now again, it's $10 increase, right? As a year go by, then you have a $10 increase. When t equal to 5, that means when t equal to 5, we should have $150, right? A equal to 100 plus 100 times 0.1 times 5, which is actually 100 plus 50 becomes 150. Okay, so constant increase, right? 1 year go by, $10 earned. Okay, and when t equal to 10, meaning now it's increased by another 5 years. So we actually end up with 100 plus 100 times 0.1 times 10. So that becomes 100 plus 100, which is $200. Still constant increase because the time t go up by 5 units, and then the interest earned go up by $50. And also, if you look at this, now it's doubling, right? It's 10 years, you see, the money has doubled, right? This is double. So 10 years, you'll be able to double the money. So this is what we call a doubling time. 10 years is doubling time. And another 10 years go by, that means money will triple, right? Double again. So triple. So A equal to 100 plus 100 times 0.1 times 20. So it's 100 plus 200 to $300. Okay, triple the initial investment. And when time t equal 50, meaning that the amount of money will be 5 times as much, because every 10 years it go up by 100%. So A equal to 100 times plus 100 times 3.1 multiplied by 50. So this is 100 plus 500. So it becomes 600. Okay. So as you can see, the simple interest actually is a linear growth model. A equal P plus PRT. And here the only thing, as you can see, the only thing varies is R times T, right? Time T is only variable part. So that's why P times RT, we can rewrite it as a linear model, and then PS actually is what we call a y-intercept. A equal to PRT times P plus P. Right, so this is the variable part. It's what we call the X, right? P is the constant, is what we call the constant part. And this is the P. The P in the back is y-intercept. So this is the linear growth model, right? So the simple interest actually follows linear growth model. It's equivalent to linear growth model. Now, let's look at a little bit more sophisticated case. So let's look at example one. So you borrow $15,000 from a friend. So after 2 years and 3 months, right, you repay the loan by giving a friend $18,000. Let's say use the money, you make some profit out of it. So you pay back your friend $18,000. And you want to find out what was the simple interest rate you paid, right, to your friend. Remember, you pay additional $3,000. That's what we call the interest, right? You pay back to your friend. So any suggestion how to get started?
Should we transform the 3 months to like point something in years?
Yes, very good. Yes, exactly right. Because remember, T must be in years, right? So this is a very good step. So 2 years and then 3 months. It's actually 3 months is 3/12, right? Because in a given year, there are 12 months. So it's 2 and then 3/12 years, right? And this is 2.25. If you turn into decimals, it should be 2.25 years. Very, very good. So this is a very good start. And what do you do after that? Any suggestion? So we know
Wouldn't you divide 18,000 by that number?
Okay, you divide 18,000 by this number, and what does that give us? You can say annual cost, right? Annual cost per year. Yeah, that works. And okay, so remember we have a formula, right? So A equal to P plus P times RT, right? If you look at this formula, this is general formula to calculate a simple interest. This is definitely a simple interest example. Simple interest. Because there's no compounding, compounding method used here. It's definitely your friend won't charge you on a monthly basis, right? Whenever you're ready to pay back, he or she will take it, right? So A is ending balance. So what is A here? Any idea?
A is 18,000.
Very good. Yes. What do you think of the P principle?
I would think that would be 15,000.
Exactly. Yes, you're totally right. And then anything else we know?
The time, the teeth, so that would be 2.25.
Very good. So now the only thing we don't know, right, is this R rate. Because remember, your friend didn't mention, what kind of interest rate will charge you. Probably your friend don't want any interest from you, but you're nice enough to pay back a little bit to make your friend happy, right? So here, the rate, it will be able to find out that once you plug into the formula here. So we know that A is 18,000, we plug in the number, and then P is 15,000, and adding 15,000 times the rate, we're looking for that, and then time T, that's 2.25 years. Again, I'm gonna skip all the units here. So now we're gonna solve for R, right? It's a linear equation with one variable. So first step is subtracting 15,000 from both sides of the equation. Okay, and also we're gonna cancel this, and then we're gonna multiply 15,000 by 2.25. Let's see what that is. 15,000 by 2.25. That's 33,750. So we get 3,000 on the left. On the right, we get 33,750 times R. Now the only variable we don't know is R, the rate, the annual interest rate. So what we can do is just multiply this by we're dividing both sides of the equation by 33,750, right, to get a rate, 33,750. Now, once you simplify, so R is equal to whatever that is, right? So 3,000 by 33,750, and that turned out to be 0.089, right? 0.089. approximately, this is approximate answer. So that means you paying back your friend at a 8.9% interest on annual basis, right? Almost like 10%. So let's say you make a lot of profit out of this initial investment, 15,000, then it's not too much, right? So that's basically how you tackle any like real life problems. It could be a real life problem, you know, you want to figure out what kind of a, let's say if you want to, for example, let's say you want to pay, you know, 10% back to your friend, let's say you'll be able to figure out how much money you'll be, the ending balance, right, return to your friend. Yeah, anything based on your actual case. Okay. So this is about it. Simple interest again. Use the formula, you know, you'll be able to solve any type of simple interest form problems. Okay, now let's move on to more sophisticated case, right? Compound interest. Okay, and then the compound interest is much better, right? Because the money works harder in a compound interest case. So you always earn more interest given the same condition, meaning with the same interest rate and also the time t, right? Given those two are the same, then compound interest is much better. You make much more money, slightly more money with a compound interest. And let's look at how that works. And this is the formula we are using here, calculate the compound interest. And here, A representing the ending balance, total amount. Also, it's what we call ending balance. Okay, and then P is principal, just like the simple interest formula. And then R is the annual interest rate. N is the number of compounding periods. And then time T is the tiny years, right? And then we call this exponential model because the base here is 1 plus, this is exponent with the base 1 plus R over N. We know R over N is always slightly bigger than 0. So the base is slightly bigger than 1. That means it's a growth model, right? It's an exponential growth model. And the exponent here is N times T. NT is exponent. And we know that it's an exponential growth model, meaning over time, you know, the money will become more and more, right? Meaning money grows faster and faster, growth model. That's why, you know, if you start your full-time job, the company will give you the 401k or any other like retirement options. And if you start putting the money into your account, by the end of the retirement age, you probably will end up with a lot of money in your retirement account. That's because of the compounding effect, right? So this compounding effect is pretty powerful. You probably hear somebody tell you that if you put the money in the stock market, you know, every 10 years or 20 years, your money may double, right? That's actually possible. In the good years, in the good, you know, years, you know, this is actually possible scenarios. Depends on the annual interest, annual return that you generate from your account. So any question on the compound interest formula? Okay, and then N here is number of compounding periods, right? So if it is compounding, let's say we have different cases. If it's compounding monthly, that means N equal to 12. It could be compounding weekly, right? Compounding weekly. And N equal to 52 weeks in a given year. It could be compounding daily. Then N equal to 365, meaning 365 days, right? Okay, so different compounding methods give us different numbers for the N. And we will take a look at that in a second. So now let's look at example 2. So let's say we have $100 and put into an account, generate 10% interest compounded yearly for 6 years. Okay. So now this is yearly compounding, right? So compounding yearly meaning n equal to 1, right? This tells us that you're getting interest once a year. That's why n equal to 1. And then here, what else do we know based on the this given information?
We know the R, the rate.
Very good. R is 10%. Right? Very good. It's 0.1. What else do we know?
And the time, T.
T. Very good. 6 years. T equals 6. And what do we call this $100?
Principal.
Very good. Perfect. So now once you know all of this given information, all we have to do is write a formula. Right, P times 1 plus R over N to the NT. So just throw in all these numbers into the formula, then we'll be able to get the ending balance after 6 years. So it's going to be 100 times principal times 1 over 1 plus rate is 0.1 over N is 1, right? It's compounded yearly. So you receive interest once per year. And then on the exponent part is N is 1 times 6. This turned out to be 100 times 1 plus 0.1 to the 6th power. And then it's 1.1 to the 6. So it turned out to be 100 times 1.1 to the 6th power. And then you just have to put into the calculator. Let's see what that is. 1 to the 6. And this turned out to be $177 and then 1561, right? And usually we just run it to 2 decimal place because we're talking about dollar amount, $177.16. That's what bank would do, right? If you, let's say you put this in the bank and then bank pay you 10% for 6 years. After 6 years, you'll get $177.16. Now let's think about this. What if it's under simple interest? Same scenario, but under simple interest, what would you get? How much money do you end up with?
160.
Very good. Yeah, so very good. So P plus PRT, right? Perfect. So you'll be 100 because every year you receive $10 interest. So six years will be $60 interest in total. And if you compare the two both cases, you know, compound interest actually slightly better, right? Because in simple interest you end up with $160, but compound interest is $17.16 more. Although it doesn't sound too much, right? But think about it. You only have $1,000. What if you have $1 million? Then the difference will be large, right? If you have $1 million to invest, or maybe even less than that, $100,000 to invest, then the difference will be a lot. Now, keep that in mind. That's why compound interest is always better off. Right? Always pick the compound interest. Now let's look at another scenario. Let's say you have $250, you match that 6.5% for 8 years. Now compounding period changes, right? Now it's compounding monthly. What does that tell us if it's compounding monthly? In essence, right, compounding monthly meaning you receive interest 12 times a year. And remember, the interest you received from the previous period will generate interest in the upcoming months. So that means, you know, the interest is also generating interest for the future. All right, so very similar here. What's given? Okay, so principal is given, right? $250. All right. Interest rate is given 6.5%. And typically we turn into a decimal number, so it's 0.065. Okay. And time t is given 8 years. Okay. And one more thing is given, it's compounding period, right? Compounding monthly, meaning n equal to 12, because there are 12 months in a given year. So that means you're receiving interest 12 times in a year. So the money, right, is compounded 12 times in a given year, which is better, right, compared to compounding yearly. Remember, on the yearly compounding, you only receive interest once a year, and you see the interest doesn't generate interest too much quicker, right? But here, compounding monthly, the interest will generate interest on a much faster pace. So now again, we just apply the formula A equal to P times 1 plus R over N to NT. Again, we're throwing all the numbers into the formula 250 principal times 1 plus R, which is 0.065 and over 12, because it's compounded monthly. Let me erase that really quickly, typo there. Go back, 0.065 divided by 12. Okay, and on the exponent part, you're gonna get 12 times 8, meaning over the life of the investment, you are getting interest 96 times, right? Because 12 times 8 is 96, so you're getting interest 96 times. So right here, you're gonna get 250 plus. So now I'm gonna show you, times. I'm gonna show you how to put this into the Excel or the calculator, because the input is slightly different. So 1 plus 0.065 over 12. Keep as is. Do not divide into that yet. So your calculator input is going to be 250 multiplied by 1 plus 0.065 over 12 and raised to, if you want to put that in the parentheses, 12 times 8, you can do that. But make sure you put 12 times 8 in the parentheses. And then I'm also going to show you how to do this in Excel. Let me open Excel really quickly. Okay. Go back a little bit. All right, let me open Excel really quickly. All right, let me share the screen with you. Okay, so in Excel, you just do this, right? $250 times exactly same plus 1 plus 0.065 by 12 and raised to 12 times 8. Right. And once you input it properly in Excel, you get a result in a much accurate form. Because when you divide 0.065 by 12, it's not a well-running number. So you're going to have infinitely many decimal places. So the more decimal you have, the better it is. So keep as is is much better. So you end up with $419 and then 92 cents, right? You run it to 2 decimal place, becomes $419.92. Okay, so your result here is $492, $491.92. Yeah, $419.92. Okay. Okay, so the result here is approximately $419.92. Okay. Yeah, under the compounding monthly. Yeah. And the more frequent compounding period, the better it is. So that being said, compounding weekly is much better compared to compounding monthly. Compounding daily is better than compounding weekly, right? You see that in a second. Okay, so example 4. Let's say you have $185,000 left in the account for 5.25 years. Okay. In account paying 4.22% interest. Right? Annual interest rate is 4.22%, compounded daily. Okay, now it's compounded daily. Compounded daily indicating you receive interest on a daily basis. So over a 1 year period of time, you receive interest 365 times. And how much money will be in the account? Okay. Anybody want to share what you see from the question so far? What's given here?
The principal, the rate, and the time.
Very good. Our principal is $185,000. Rate is 4.22%. So it turned into decimal will be 0.0422. Also the time, right? It's 5.25 year. So again, we turn into decimal is 5.25 years. Okay. Again, decimal is it's much better, right? Compared to the fraction, because it's much easier, you know, when you put into the formula using the decimal number. Also, we know the compounding period, right? It's daily. That means n equal to 365. Okay. So we know all 4 things, right? And then the only thing we don't know is ending balance, 8. So we're going to apply the formula over n to nt. Okay, then one more time, throw in all the given numbers, 185,000 times 1 plus R is 0.0422 over 365. And again, keep as is, right? Do not divide into that and then get an approximate answer that may impact the final result. Think about it. If you a bank, if you run into 2 decimal places when you do this, calculation, then your answer will be off a lot, right? So that means the bank may end up losing a lot of money, you know, may end up paying much less interest to you, to their customer. That's not good. That customer won't be happy, right? If that happens. So that's why in terms of dealing with this, you want to keep it as accurate as possible in order to guarantee that you're gonna leave as is. Okay, so n is 365 times t will be 5.25. Now again, I'm going to show you how to do this in the Excel or the calculator. So one more time, I'm going to turn into the Excel. So the given amount, principal is 185,000 multiplied by 1 plus the rate is 0.0422. Okay, and divide that by 365. Okay, that will be the base. And raised to exponent is 365 times 5.25. 5.25. Okay. And once you input like that, you guarantee you have a very accurate answer, right? The most accurate answer you can have. The bank actually do the same thing, right? They will put into the calculator or like their fancy software, you know, to get the result. And then you're gonna end up this, right? End up with $230,878 and 80 something cent. Let me just 83 cents. Okay. And make sure you know it's run it to 2 decimal place because that's more accurate. Okay. Right, so it's $230,878 and 83 cents. Okay, that's ending balance under these circumstances. Okay, so your answer is, one more time, 230,878.83. 230,878.83. Okay. So that's ending balance after 5.25 years. Okay. Any questions so far? And again, we're still working on this formula, right? Let's stick with the same formula. The only thing is the terms changes, like time t changes, interest changes, principal amount changes. Could be the compounding method changes, but the formula stays the same. Okay, now look at this. Let's say you have $1,250,000 is left in account for 11 years and 5 months. And notice that now it's 11 years and 5 months. And they're paying 2.58% and 2.58% interest, compounding monthly. How much money will be in account? Okay. So one more time, how do we deal with the time t here? Any suggestion? So now it's compounding monthly, right? So if we convert 11 years and 5 months to months, since it's compounding monthly, so time t is 11 years and then 5 months. And we know that this is 11 and then 5 over 12. Okay, years, right? And we turn into a fraction first. And since the reason why I didn't turn into a decimal, because 5 by 12 is not a well-rounded number. So you do not want to lose the accuracy here by turning to decimal numbers. So you stick with the fraction for now. And typically we will turn this into a improper fraction. So 11 by 12 times 12, adding 5, then turn out to be 137 over 12 years. Notice that I stick with the exact answer, right? I did not round it. Okay. So now next thing is we are given a principal amount, right? It's $1,250,000. And we also know that interest rate is 2.58%. And this is possible to turn into an exact answer. So 5 by 8, we get an exact answer 0.625. So this is 2.625%. Now turning to decimal will be 0.02625. Notice that if it is well-rounded answer, I turn your decimal because it's more convenient. But for time t, it's not well-rounded answer. So you gotta keep it as is to make sure we have end up with the accurate answer. And then also we know the compounding period n is 12. Now one more time, we just have to use the formula a equal to principal times 1 plus r over n to nt. Okay. Now we throw in all the given numbers, and then the principal is 250,000 times 1 plus the rate is 0.02625 over 12. Now exponent t is 130, n is 12 times 137 over 12. As you can see here, we're going to cancel the 12, right, on both top and bottom. That's why this total compounding period for 11 years, 5 months is 137 months. And that's why we have this well-rounded answer now. So once you have this, then we're going to turn input into the calculator or Excel. Over 137 power. Okay, and let's see what that is, right, approximately. Now I'm going to share the screen with you. So here we go, we do this. Equal to 1,250,000 multiplied by 1 plus 0.02625 and divided by 12. And then the power is raised to 137 power. Since single number, no parentheses needed. Now if you enter, you will get a result. Yeah, that, let me just run it. Currency 2, great. So that's turned out to be $1,686,244.30. Okay, so this should be the answer, right? Okay, and let's go back here. So this answer turned out to be 1,686,244.30. And if I want to ask you how much total interest generated in those 11 years and 5 months, what do you think? So this is the ending balance, right? We get ending balance here. It's $1,686,244.30. And the beginning balance, $1,250,000. What do we call the difference between those two? Any suggestion? The difference between those two amounts?
The interest.
Exactly, very good. So the interest generate over all those years, 11 years and 5 months, and we can calculate that quickly. It's $1,686,244.30 minus 1,250,000. The difference is what we call the interest earned over all those years. And let's see what that is. Again, you can try in calculator or Excel. And the answer turned out to be $436,244.30. Yeah. That means over 10 years, that's total amount of interest earned. That's fairly large amount of money, right? Over slightly over 10 years. So the return is, okay. So this is basically return on investment over this period. Now think about this. This could be an actual case, right? Let's say you need $25,000 to buy a car, right? Let's say graduate from college, you work in another state, you need a car. And how much do you have to put into the account? Yielding 5.75% compounding monthly in order to have 25,000 in 5.5 years. So basically you could open a brokerage account, right? Meaning you open an investment account and then pick a banker, and then the banker tell you, give me this amount of money, I will make sure you get $25,000 in 5.5 years. Okay, so what are we looking for here?
We need to find the principal.
Exactly, very good. Principal is not known. Okay, and we know several things, right? We know 25,000. What is that? That's a future value, right? Meaning 25,000. You need $25,000 in 5.5 years. Let's say maybe in the middle of high school, you decide, maybe you have a plan. So 5.5 years after you graduate from college, you're gonna buy a car, right, with $25,000. And then your parents decide to finance you with this, right? And tell you to go to an investment bank or like a brokerage firm, tell them to open an account for you. So 25,000 here will be the ending balance, right? So we know ending balance, 25,000. That's the goal, that's the target. And we definitely know the rate, right? 5.75%. Rate is 5.75%. This is 5.75%. And your decimal number is 0.0575. We have that. And we know time t, right? 20 is 5.5 years. So this is easily converted to the 5.5 years. Okay. Now compounding period, right? It's compounding monthly. So that means n equal to 12. We know that. Now the only thing we don't know is principal, right? So we have a equal to p times 1 plus r over n n t. Okay. So if you just look at a formula, in order to get p by itself, you will divide both side equation by this 1 plus r over n to the nt. Okay, on both side equation. And you cancel that, then principal is by itself. And that's what we're looking for, right? So principal is equal to ending balance 25,000 divided by 1 plus r over n to the nt. Now all we have to do is throw in our numbers into the formula and solve for p. So here 25,000 divided by 1 plus 0.0575 over 12, n equal 12, and then n equal 12 times 10t, which is 5.5. All right. I'm going to show you how to put this into the Excel or the calculator. They have similar input. Okay, let's do it. So here we go with the equal sign first. So the ending balance 25,000 divided by 1 plus rate is 0.0575 divided by 12 and raised to 12 compounding period per year times 5.5. Okay, 5.5 years. And this is a proper input. I probably should put another parentheses here, but it doesn't matter because exponent it's attached to the base. But if you really want to put an exponent in front of put in the denominator, you could do that. Okay, and the result is this. If you skip the exponent on the denominator, it should be also good. You'll get the same result. Same result. Yeah. So one more time, we can run it to decimal place. Okay, here we go. So that means you should provide a banker or the investment advisor, right? $18,235.70. And then in 5.5 years, you end up with $25,000 of your target. Okay, let's go back. So the result here is 18,000. $235.70. If you think about this, right, the total interest earned in this account over only 5.5 years is quite substantial. If you look at it this way, you get $25,000 ending balance minus initial balance of $18,235.70. The difference is what we call interest. Should be 25,000 minus 18,235.70. And this is $6,764.30. So the yearly return, if you divide that by 5.5, right, you're going to get yearly return it's about $1,352.86. And this is pretty good investment, right? And then if you think about 5.75% compounding monthly, this is actually not very difficult to achieve, right? In the good years, in the regular years, you know, this is very reasonable investment outcome. Yeah. Okay. All right. Any question on this? So again, anytime when you look at this kind of scenarios, always list what's given here. Make sure you label them, properly, and always ask yourself, what are we looking for, right? What's missing here? And we'll be able to get to that once we lay out all the information here. Now here is solving for t, right? It's specifically tell us solving for t. So how long, right? How long will it take for 28,000 to grow to 50,000 at a 3.75% compounding monthly? Definitely, we know we're looking for t. Okay. And the given information here is principal, right? Principal amount is 28,000. And then ending balance A is 50,000. Okay, no doubt. And then interest rate is 3.75%, 0.0375. Compounding period 12 monthly. Okay. So that's all given. Then the only thing we don't know is time t. Okay, so the only thing we're looking for is time t. So A equal to P times 1 plus R over N to the NT. However, the t is in the exponent, right? Remember in chapter 2, actually, in section 2.3, actually, we deal with some of these examples when we try to solve a time t, right? Very similar procedure here. So first of all, we put in the numbers, 50,000 equal 28,000 times 1 plus rate is 0.0375 by 12. And then N is 12. Time t, right? Time t is what we're looking for, 12 times t. Now, first of all, in order to isolate the exponent, we're going to divide 28,000 from both sides of the equation. Okay. If you want to drop the zeros in the back, you can do that, right? Drop 3 zeros. Now, simplify that, we're going to get 1 plus 0.0375 over 12 to 12t. That's equal 50 over 28. All right, now in order to get rid of the base, what we do is taking the ln from both sides of the equation. Using the logarithm property, 12t. So now 12t will become the coefficient. Yeah. So this ln of 50 over 28. Okay, now 12t goes in front. 12 times t times ln of 1 plus 0.0375 over 12. That's equal to ln of 50 over 28. Now, in order to solve for t, you just divide both sides of the equation by 12 times ln of 1 plus 0.0375 over 12. And we get down to the bottom of it like this from both sides of the equation. Times ln of 1 plus 0.0375 by 12. Okay, so we cancel the 12, cancel ln, then t is by itself. And let's see what that is. Now again, we're going to use the calculator. So it's ln of that by this 12 times the ln of the other number. So go back to the Excel. So we're going to get ln of 50 over 28 on top. And denominator, we're going to have 12 times ln of 1 plus 0.0375 by 12. And close another parentheses for denominator. Now, once we complete that, then hit enter. Then that means it's about 14 years and then 15.5 years, right? If you run it to one decimal place, usually that's what we need. So 15.5 years. Okay, 15 years and then 6 months, right? About that. Then this investment will go from 28,000 to 50,000, almost doubling, right? So 15.5 years. Yeah, so this is the question number 8. Any concern, any like questions on this? So basically we solving for different elements in a formula. And next one, we probably gonna solve for R, right? Solve for interest rate. So very similar, okay, no, this is wrong question. Okay. This one actually is a typo, so you can ignore the, go to example 10, yes. This question actually it wasn't worded correctly, so I'm gonna modify that right now. From current slide. So for rate, yes. So for R, right? So we need to have a question. So let me quickly change the term. For question 9, I forget to modify the wording. Okay, so let's say how long, right? What interest rate? Take for 20,000 to grow to 50,000 compounded monthly in, let's say in 8.25 years. Let's look at this one. Let me see. I post this updated version of the PowerPoint presentation later. Okay, but yeah, let's focus on this right now. Current. Okay, so here we're solving for the rate. Okay, what interest rate would take for 20,000 to grow to 80, 50,000 compounding monthly, right, in 8.25 years. Okay. So very similar condition. The only thing we don't know is R. Okay. So we know the principal, 28,000. We know the ending balance, 50,000. And we know that we know the time t, right? Time t is 8.25 years.
Professor,
Yeah.
we can't see your screen.
Okay, all right. So I probably forget to share that. All right, so let me reshare that. Okay, here. Can you see the screen now?
Yeah.
Okay, very good. So this question now we're talking about, I modified the question. I forget to change a couple of things here. So yeah, this is the question. What interest rate would take for 28,000 to grow to 50,000 compounding monthly in 8.25 years? Okay. And first of all, we look at all the given information here. Principal is 28,000. Ending balance is 50,000. Time t is 8.25 years. Number compounding period is 12. Okay. And the only thing we don't know is R, right? So basically solving for this missing element R, annual interest rate. All right, so again, we plug into the formula, P times 1 plus R over N to NT. Okay, so first of all, let's throw in our numbers into the formula. A is 50,000. And then principal is 28,000. 1 plus the rate is what we're looking for rate of 12. And N is 12 times t 8.25. Okay. And basically, we're just solving for R, right? So basically, we want to isolate this variable term. So dividing 28,000 from both sides of the equation, just like the other one. Okay. So now cancel 28,000. Yeah. So and then multiply 12 by 8.25. I think it's a very round number. It's 100 basically. 12 times 8.25. And actually it's 99. Yeah, it's 99. So I don't know why we can cancel all 3 zeros here. Okay, so it's 50 over 28. Like, make it slightly simpler. 99 power equal to 50 over 28. Now here, it's slightly different from solving for t, right? We are solving for r. That means we need to get rid of the exponent here. So the way how we arrange it is using this property, right? Let's say a to the x to the y becomes axy. We're using exponential properties. So we're going to use a reciprocal 99, meaning we're going to raise this power to 1 over 99. Okay, and then same thing on the right, right? We're going to raise this to the power 1 over 99. And applying this exponential property, when you multiply 99 and 1 over 99, it becomes 1. So we get rid of the exponent. So it becomes 1 plus r over 12 to the first power. Because 99 times reciprocal becomes 1. And on the right, it becomes 50 over 28 raised to 1 over 99 power. Now from there, 1 plus r over 12 equal to 50 over 28, 1 over 99. Step 1, subtract 1 from both sides of the equation, right? Get rid of the constant. Then we get r over 12 remains, and that's equal to 50 over 28 raised to 1 over 99 power minus 1. And then the very last thing, in order to get r by itself, we just multiply 12 from both sides of the equation and put this in the parentheses, multiply that by 12. Okay. So 12 cancel the denominator, then r is by itself. So eventually r is approximately equal to this whole thing, right? Then one more time, I'm going to show you how to put this into the Excel. All right, so we have a equal sign, open parentheses, open other parentheses. The first one is 50 by 28. Close that, raised to 1 over 99 power. And close parentheses, minus 1. Okay. Then raised to, no, not after that, multiply by 12. Forget to put an equal sign here. Minus 1, yep. Okay, close parentheses. Yep, and then multiply by 12. Okay, let's do it. Okay, try to input or put into the calculator, right? This should be similar input. Then this is the result. And we run it to 4 decimal place. 0705. Okay, so the answer is 7.05% over this amount of time. So it's 0.0705. So it's 7.05%. Okay, with that interest rate, this will be accomplished. This goal will be accomplished in 8.5 years, 8.25 years, okay, compounding monthly. Okay. Any question on this? All right. Again, I'll post this, repost this updated version of the PowerPoint in a bit. We'll finish the lecture. Okay, and then example 10, you're looking at tripling time. Okay. In your exam number 1, remember we have a doubling time and also have a tripling time. And now let's look at it. So how long will it take an investment to triple in value at a 4.65% compounded weekly? Okay. So here, what's given here?
We have T, we have the principal and the final amount. We
Yep.
have N.
Yes, and is 52, right? 52 weeks in a given year. Okay, we know the rate is 4.65%, 0.0465. although we don't know the principal, right? But we can assume principal is 1 unit, right? And tripling meaning the ending balance will become 3 units, whatever that is, right? I mean, it becomes 3 times as much. Okay, so that basically we have all this information given. So the only thing we don't know is the time t. So we are solving for time t. So A equal to principal times 1 plus Ln. Very similar procedure like the example number 8. So putting the number, so 3 equal to 1 times 1 plus the rate is given 0.0465 divided by 52. 52 weeks in a given year. And the n is 52 times t. T is what we're looking for. Okay. So now very similar. We can omit that 1, right? So basically it becomes 1 plus 0.0465. I'm reversing the order. 52t equal to 3. In order to get rid of the base, in order to get rid of the exponent, I'm putting in the front. We're taking the ln from both sides of the equation. So ln of the whole thing. So 52t. And on the right-hand side is ln of 3. Okay. We'll put in parentheses, that works. All right, now 52t goes in front. So in front. So end up with 52t. And ln of 1 plus 0.0465 over 52. Okay. Yeah, and then equal to ln of 3. Now we need to get rid of the 52 and ln of the 1 plus 0.0465 by 52. So dividing both sides of the equation by that. And same thing on the right-hand side. Divide by 52 times ln of 1 plus 0.0465 by 12, 52. And then we cancel that, and t is by itself. T is approximately equal to that. Now, one more time, we're going to throw into the Excel calculator. So now that's to get the final result. So we get ln of 3 by open parentheses. I get 52 multiplied by ln of 1 plus 0.0465 over 52. Yeah. Okay. Then we close parentheses. I should get the answer right away. Okay. Once you input it properly. Yeah, here you go. We get 23.6, right? 23.6 years. So that means it take about 23.6 years for this to become reality. Okay, 23.6 years. Okay. Now we're talking about tripling here. Okay. So any investment or any activity, any investment activity follow the same principle, right? For the same compound interest formula. And that's everything on section 3.1. Let's go back to the exercise and let's take a look at some of the exercise in the back of the textbook. So I want you to open the textbook really quickly and go to section 3.1. And let's turn to page 90, I believe. Actually not 90, it's maybe 70. Yep, and right. Okay. And maybe you look at question 2, right? Give you a couple minutes, think about question number 2. Okay. A friend borrowed $2,500 from you, agreeing to pay 3.85% simple interest. The loan plus interest is to be paid back after 7 years. When the loan is repaid, how much will be the interest portion of the repayment? Will be the total payment repayment, including the interest and the principal. Okay. Try that. All right, let's look at the solution. Okay, really quickly. All right, so we are given a principal, right? $2,500 is principal. And we also know the interest rate. Annual interest rate is 3.85%. It's turned out to 0.0385. Okay, and we also know the time t, 7 years. Okay. So first of all, you want to find out the interest portion. So interest equal to principal times rate times time t. Okay, simple interest formula. Now throwing all the numbers, 2,500 times 0.0385 times t, 7. And that turned out to be 2,500 times 0.0385 times 7. So the interest, pure interest part is $673.75. Right? Total repayment, right? This is just interest part. Total repayment includes principal and interest. So the ending balance with principal plus interest. Okay. So that'll be 2,500 adding $673.75. And each turned out to be $3,100 $173.75. Okay. And that will be the total repayment. Okay. All right, so this is question number 2. Now let's go back, look at question number 4. 4 and 6, right? I want you to work on 4 and then 6. I'll give you 5 minutes. Okay, so let's go over the solution here for question 4 and 6. Okay, let me put in the screen really quickly. Okay. I'll share the screen with you. Okay, question 4. So we have this $8,000 grow to $12,000 at 5% a year, simple interest, right? So how many years? So looking for time t here. So using we know the principal is $8,000, ending balance $12,000. Rate is 5%, 0.05. The only thing we don't know is time t. So plug into the simple interest formula. Okay, so this is the missing element. So 12,000 equal 8,000 plus 8,000 times 0.05 times t. Okay, then simplify 12,000, 8,000 plus 8,000 times 0.05, that will be 400 times t. And subtract 8,000 from both sides of the equation. So we end up with the 400t equal to 4,000. Then you want to solve for time t, you divide both sides of the equation by 400. T is equal to 10. That means it takes about 10 years, right, to grow the money under these particular circumstances. Next question 4. Question 6. 37,500 deposit into account, paying 5.25% compounding monthly. So this is definitely, this keyword indicating is compound interest. After 8 years and 5 months, how much will be in the account? Okay. So first of all, we know the principal, 37,500. Rate is a 5.25%. It's 5.25%. It's 0.0525. You convert percent to a decimal, and time t is given. It's 8 years, 5 months, and we turn into a fraction. It's 8 and then 5/12. And typically we will keep it as an improper fraction. 8 times 12, 96, adding 5 is 101/12 years. Okay. Now again, we're looking for the ending balance. Okay. A is what we're looking for. So principal times 1 plus R over N. N, I forgot to mention, N is equal to 12. So R over N over NT, raised to NT power. Now one more time, we throw in on the numbers. 37,500 times 1 plus 0.0525 over 12. N is 12 times 101 over 12. And we know that we can cancel the both 12. And the power will become 101. So it's 37,500 times 1 plus 0.0525 over 12 raised to 101 power. One more time, you're going to put into the calculator, get a result. 37,500 times 1 plus 0.0. 525, yeah, 525. Divide by 12, raised to 101st power. Okay, and that should be it, right? You enter, you get $58,279 and then 60 cents. So the answer here should be 58,279 and then 60 cents. Okay, and that's the answer for question number 6. Okay. And let's look at the question 8 and 10, right? And let's go over the solution for question 8. Okay. So on question 8, actually there are 3 different cases here, right? And it's a very good question, so we can use to compare the yearly compounding, monthly compounding, and daily compounding. All 3 under the same given condition. So let's say yearly compounding first. Yearly. Okay. The yearly compounding. So the initial investment principal is $10,000. And the rate is given, it's 4.78%. 7 over 8 is 0.875, right? See. Yes, 0.875. So this is actually 4.875%. So it's 0.04875. Okay, that's rate. And then we also know the time t. Time t is 10 years. On yearly compounding, so n equal to 1. So now once we know all these, plug in the formula p times 1 plus r over n to nt. Then throwing all the numbers into the formula, so 10,000 times 1 plus the rate is 0.04875 over 1. And on the exponent is 1 times 10. So it's raised to 10th power, so this turn out to be 10,000 times 1 plus 0.04875 to 10th power. And let's see the result. You can also try that in the calculator. Times 1 plus 0.04875 raised to 10th power. And this result turned out to be $16,096 and then 7 cents. Exact answer. Now let's look at the monthly compounding. Everything else being the same except the compounding period. P is $10,000. Rate is 0.04875. T is 10 years. N equal to 12. Okay, so that's crunch number one more time. A equals to 10,000 plus 0.04875 over 12. And the exponent is 12 times 10. So you're receiving interest 120 times. So one more time, I'm using a calculator or Excel. The 20th power, let's see what that is. 10,000 times 1 plus 0.04875 by 12 raised to 120th power. And this turned out to be 16,266 dollars and 33 cents. If you look at it, this is bigger than that, right? Now let's look at the daily compounding. Okay, we expect to get most money out of daily compounding. About 10,000. Rate same, 0.04875. T is 10 years, N equal to 365 days now. Okay, because of daily compounding. Okay. So one more time, we're going to do 10,000 times 1 plus 0.04875 over 365, and on the exponents 365 times 10. So 3,650 on the exponent. One more time, you put into the Excel calculator. And this turned out to be 16,281 dollars and then 88 cents. Again, comparison among all three amount. This is the highest return, right? The second highest, and then, so that means, so this general principle is more frequent compounding. Renders more return or more interest, right? More return indicating more interest. Okay. So you think if it is continuous compounding, that would be the best, right? Meaning we split time to infinitely many intervals, right? So this power becomes infinity, then it becomes the best compounding method. Okay, but this is a general like principle we can generate out of this. And question 10 is changing 18.679 years to years and months. And we did a similar practice earlier in chapter 2. So 18 point question 10, 679 years. We know it's 18 years. And multiply 0.679 by 12 months. Let's see what that is. Years, 0.679 by 12. That's 8.148 months. If you want to turn it the months into days, you can keep going, right? 18 years, 8 months. Multiply 0.148 by 30 days. Let's see what that is. That's 18 years, 8 months. And let's see, 0.148 times 30, that's 4.44. If you want to keep going, right? 1 day equal 24 hours, right? You can keep going until you reach you totally, you know, expand it to the lowest units, right? Like seconds, you can actually run into seconds if you want to do that. But yeah, 18 years and then 8.148 months, right? If you, for this question. All right. Any question on this section? All right. If you have no other question, I will stop here. I'll talk to you guys on Friday. Okay.
Thank you.
No problem. Bye-bye, guys. No
Thank
worry.
you.
Okay. No problem. Bye.
Bye. Thank you, Professor.
No problem. Bye-bye.